For this question, we're asking to find the horizontal asymptote of the graph y equals 5 plus 2 to the x power divided by 1 minus 2 to the x power in the xy plane. So in this question, we can approach it with two ways. So first of all, we need to think, well, the horizontal asymptote is where the limit as x approaches infinity. But don't forget, there's also x approaches negative infinity can be our horizontal asymptote. So we will talk about it in two conditions. The first one is where x approaches positive infinity of the original function. So if that's the case, then we know that as 2 to the x power approach, like 2 to the x power, like x approaches infinity, then this whole thing will become positive infinity, right? So it will become a positive infinity divided by a negative infinity. So basically that's like not definite, so it's like an indefinite format, but we can't think about that way. So because 5 and 1 in here are not important anymore, because as x approaches infinity, the constant does not matter. We are basically talking about the speed, like is it the upper function moving faster or the lower function moving faster. So we can, like, the whole function will just simply be limit as x approaches infinity of 2 to the x divided by negative 2 to the x. So 2 to the x will be cancelled, so the whole limit will become negative 1. Okay. So this is one condition, and another condition is when limit as x approaches negative infinity. Sorry, there's a negative in front of here. It's not very clear. Of the original function. So if we put the negative infinity into x, then it will be 0 on both. So it will be 5 plus 0 divided by 1 minus 0. It will just basically be 5. So the horizontal asymptotes, there's two horizontal asymptotes for this function. It will be negative 1 and 5. So y equals negative 1 and y equals 5. Okay, and let's keep going. So let f be a function with the second derivative given by f prime of x is equal to x to the square, this thing. And what are the x coordinates of the points of inflection of the graph of f? Okay, so do this by yourself first. Okay, so for this function, because it asks us for the coordinates of the points of inflection, we know that we have to find the f double prime of the function in order to find the points of inflection. But the good thing is that the original question already given us the f prime of x. So that's good. The only thing we need to do is set it equal to 0. Okay, so we can get 3 x values, 3 zeros basically. So, but we have to draw a number line for this to test its signs. So if we put a negative 1 into the function, then negative 1 to the second power will be 1, positive, negative, negative, so this will be positive. 1 into the function, 1 times negative, it will be positive. 4 positive times negative, so negative. 7 positive, and positive. Okay, so we know that in the f function will be concave up, concave up, concave down, and concave up again. Sorry, ignore this. But we have to make sure one thing. What's the definition of point of inflection? Because I saw a lot of students just say like there's 3 x values where the points of inflection occurs, 0, 3, and 6. But it's actually wrong, because the definition of point of inflection is where the original function changes concavity. this is really important. So we can see that from F, at which point does it change from concave up to concave down, or from concave down to concave up? Well, it will be 3 and 6, right? So because 0 in here, it's also pretty clear if you want to approach it from the F of double prime side. It does not change signs, even though 0 in here it's a 0, like 0 is a 0, kind of strange, but that's the case. So there's no sign change on both sides of 0, so it does not count as a point of inflection. So only 3 and 6 are points of inflection, so the answer will be 3 and 6 only. Okay, yeah, let's move on. So there's a particle moves along a straight line. The graph of the particle's position x of t at time t is shown above for t is greater than 0 and less than 6. So this graph is x of t. The graph has horizontal tangents at t equal to 1 and t equal to 5 and a point of inflection at t equals to 2. For what values of t is the velocity of the particle increasing? So increasing, which means that f prime has to be greater than 0, which means that the velocity has to be greater than 0. Well, not only of that. So the particle has to increasing, the velocity and the acceleration has to have the same sign. So either velocity is greater than 0 and acceleration is greater than 0, or velocity is less than 0 and acceleration is also less than 0. They have to have the same sign. Okay, so we want to know that for what values of t is the velocity of the particle increasing. So we want to find the exact value of v, of t, for the velocity function. Okay, so I think the good way to do it is by first finding the number line of v of t. Yeah, like looking at the original function, which interval is increasing, which is decreasing. So 1 and 5, 1 is decreasing and increasing and decreasing here. So correspond to the original function, it will be decreasing, increasing, and decreasing. Okay, and also we have to test out the acceleration function. Its changes concavity. We already know that 2 is given to us as a point of inflection. So 2 is approximately at here. We know that below 2 it's concave up, so it will be positive, and above 2 will be negative. So what we want to know is that at which interval is velocity and acceleration has the same sign. So negative infinity to 1 cannot be the answer, and 1 to 2 is good because they both are positive, and 2 to 5 cannot be that. Also 5 to infinity can also be the answer. Yeah. So let me take a look. But we know it's like restricted from here. It's 6. So it's from like 5 to 6. Let me take a look. So negative cannot be here, and 1 to 2 is positive, so it's good, but the velocity is increasing where the acceleration has the same sign with velocity, so this cannot be here, and this positive is in here. Oh, you know what? I'm so stupid. I'm so sorry. Okay. So for this question, because it's asking us the velocity increasing, what we have to find the acceleration is positive. That's the only thing we have to find. Yeah, and so acceleration is increasing from like 0 because time cannot be a negative. So 0 to 2 will be our only answer for this question. I'm so dumb. So sorry you guys, but just want to say that because it's asking us for the velocity is increasing, velocity is the derivative of position, and acceleration is the derivative of velocity. So we only have to find the acceleration. That's the only thing we care about. So don't have to care about which is which, and where velocity and acceleration have same or different signs. That's not the thing we care about in this question. Okay, I hope you learned something from this video. Thank you.